All right, think of this as the height and width of a rectangle. And we're adding up a bunch of rectangles areas. If that wasn't clear, it might be if you expand it a little bit. All right, if we expand this, then 1k is 1. We have this expression, plus 1k is 2, and 3, and so on. As you can see, we basically have a length and width of a rectangle, and the rectangle's width is always 1 over n, the way it is with Riemann's sums. So we need to know what the height is, and to express that as a function. All right, let's take a look graphically. We don't really know what this curve looks like exactly, but we need to find its function, and it probably involves a square root, which is why I drew it this way. All right, so when we put input into the function, the output is the y value, which is its height. So let's draw a picture of one of these rectangles. Let's look at another one. Let's look at one more and consider each rectangle's width and height. So the widths are all exactly the same. They're 1 over n. So if this function was just the square root of x, then what would the height of the first rectangle be when k was 1? Would it be the square root of 1 over n? The answer is yes, because the x value here is 1 over n. And when we put it into this function, we get the square root of 1 over n, which is the y value, which is the height of a rectangle. So there's the height of the rectangle times the width. Now look at this second rectangle, which is here. Well, its width is definitely 1 over n, check. What about its height? The height comes from this point right here, which is the y value when we put this x value in. And that x value is 1 over n plus another 1 over n. So that x value right there happens to be 2 over n. And so to get the height of this rectangle, so that we have its width times height, we'd put in the x value, 2 over n, into this function and get the square root of 2 over n, its height. And that works all the way down the line. So we can see, therefore, that this series, the limit as n approaches infinity of this series, is going to be the area under the red curve, because we're getting a number of rectangles approaching infinity, which means it's getting closer and closer to exactly the area under the red curve. It's essentially equal to it. So maybe we can figure out what this is equal to then with a definite integral. The definite integral of the square root of x dx. And you can see that we started at 0, and how far do we go? Well, what was our last x value that we input into our function f to get our height for the last rectangle? It was n over n, which is equal to 1. So there we go, and that's how we find the answer to this question. The antiderivative of the square root of x is 2/3 x to the 3 halves. Evaluate from 0 to 1. That gives us 2/3 minus 0, or just 2/3. Answer choice C.